The study of magnetic fields dates back thousands of years, with early civilizations observing naturally occurring magnetic phenomena. Ancient Chinese, Indian, Greek, and Egyptian cultures documented the use of lodestones for navigation and divination purposes. In the 13th century, European explorers like Marco Polo described the use of compass needles for navigation, attributing their alignment to Earth's magnetic field. This discovery revolutionized maritime exploration and trade routes. The scientific understanding of magnetic fields began to take shape in the 16th and 17th centuries. William Gilbert conducted systematic experiments with magnets and lodestones. In his seminal work, The Magnet, published in 1600, Gilbert proposed that Earth itself was a giant magnet with magnetic poles. In 18th century, scientists like Hans Christian Ørsted and Andre Marie Ampere made significant contributions to the field. Ørsted's discovery of electromagnetism in 1820 demonstrated the relationship between electricity and magnetism, laying the groundwork for the study of magnetic field in electromagnetism. Michael Faraday's experiment in the early 19th century further advanced the understanding of magnetic fields. His work on electromagnetic induction and magnetic field lines led to the development of Faraday's law of electromagnetic induction, a foundational principle in physics. James Clerk Maxwell's equations, formulated in the mid-19th century, provided a unified framework for describing electric and magnetic fields. Maxwell's equations revealed that changing electric fields could induce magnetic fields, and vice versa, elucidating the dynamic nature of electromagnetic phenomena. In the 20th century, the advent of quantum mechanics and Einstein's theory of relativity deepened our understanding of magnetic fields at both atomic and cosmic scales. Today, magnetic fields play crucial roles in various fields, including particle physics, astrophysics, material science, and technologies, shaping our understanding of the universe and driving technological innovations. A magnetic field is a fundamental concept in physics that describes the influence exerted by magnets and electric currents on surrounding objects. It is a region in space where magnetic forces are experienced by charged particles and other magnetic materials. A magnetic field is a vector field that represents the distribution of magnetic forces in space. It is characterized by both magnitude and direction at every point with the field. The strength of the magnetic field is typically measured in units of Tesla or Gauss, while the direction is indicated by the orientation of magnetic field lines. Magnetic fields are generated by moving electric charges such as electrons in atoms, and by magnetic materials such as permanent magnets or electromagnets. According to Maxwell's equations, electric currents produce magnetic fields, and changing magnetic fields induce electric currents, illustrating the intimate relationship between electricity and magnetism. Magnets possess several distinctive properties that distinguish them from other materials. Here are some key properties of magnets. Directionality. Magnetic field lines always form closed loop, extending from north pole to south pole of a magnet or from positive to negative terminal of an electric current. The direction of magnetic field at any point is tangent to the field lines. Strength. The strength of a magnetic field diminishes with distance from its source, following the inverse square law. Closer proximity to a magnet or current-carrying wire results in stronger magnetic forces. Polarity. Magnetic fields exhibit polarity with north-seeking poles and south-seeking poles. Like poles repel each other, while opposite poles attract, as described by the law of magnetic poles. Interaction. Magnetic fields interact with charged particles and magnetic materials, exerting forces that can attract or repel objects. This interaction is governed by Lorentz force law, which describes the motion of charged particles in magnetic fields. The application of magnetic fields spans across a wide range of industries and technologies, playing a crucial role in numerous everyday devices and processes. Here are some key applications of magnetic fields: electric motors and generators. Magnetic fields play a crucial role in the operation of electric motors and generators. By passing an electric current through a wire coil within a magnetic field, electromagnetic forces are generated, leading to the mechanical motion in motors or the conversion of mechanical energy into electrical energy in generators. MRI machines. Magnetic resonance imaging machine utilize strong magnetic fields to produce detailed image of the body's internal structure. These machines align the magnetic moments of hydrogen atoms in the body's tissue and then perturb them with radio frequency waves. The resulting signals are processed to create high-resolution images for medical diagnosis. Compasses and navigation. Compasses utilize Earth's magnetic field to determine direction, making them indispensable tool for navigation. By aligning with the planet's magnetic field lines, compass needles point towards magnetic north, aiding travelers, explorers, and sailors in finding their ways. Now it's time for frequently asked questions about magnetic field. How are magnetic field lines formed? Magnetic field lines are imaginary lines used to visualize the direction and strength of a magnetic field. They are formed by plotting the path that a small compass needle would take when placed in the vicinity of a magnet or a current-carrying wire. How does a compass align with magnetic field lines? A compass needle aligns itself with the magnetic field lines of the Earth. The north-seeking end of the needle points toward the Earth's magnetic north pole, while the south-seeking end points toward the magnetic south pole. Can magnetic field lines be distorted or manipulated? Yes, magnetic field lines can be distorted or manipulated by the presence of magnetic materials, electric currents, or changing magnetic fields. This phenomenon is exploited in the technologies like magnetic shielding, magnetic confinement fusion, and magnetic resonance imaging. This is just a brief exploration of magnetic field through history, definition, properties, applications, and frequently asked questions. As our understanding of magnetism continues to advance, we can expect to see further innovations and development that harnesses the power of magnetic fields for ever more practical and groundbreaking purposes.